Well, hello and welcome to today's webcast. Today is an Alpha Anywhere demonstration. It's a little bit different than our normal Alpha Anywhere demo and Q&A sessions. Dean McCormick is away this week. He will be back next week to do your Q&A sessions and to do another demonstration. But I'm here today. I'm Dave McCormick, the VP of Product Management here at Alpha Software. And today I have got a presentation which I think that you will find interesting. At least I hope you do. And it has to do with the Internet of Things. So let's get started. I'm also joined today by Chris Martin. Hello, Chris. Are you there?
I'm here. I can see your screen. Everything looks good.
Excellent. Just want to make sure of that. Thank you very much. So let's get started. So many of you may have heard the term Internet of Things, but let me just sort of help clarify and define what I'm talking about and what it has to do with Alpha Anywhere. So Google, for lack of a better source, defines the Internet of Things as a proposed development of the Internet in which everyday objects have network connectivity, allowing them to send and receive data. Now, I think we're all pretty familiar with sending and receiving data, part of this, and network connectivity all makes sense. But what are we talking about when we're talking about everyday objects? Well, one thing that comes to mind would be the sort of the home automation movement that's taken over, which is something that's sort of been following factory automation, train station automation, airplane automation, all kinds of things. But basically what it is objects that you normally had, like your thermostat or your refrigerator or your washing machine, now have embedded microcontrollers in them and sensors and the ability, and more importantly, the ability to communicate to a network. So if you take a look at the first one, the Nest thermostat, fairly popular example. There are other ones out there now as well. I think Honeywell makes one, but this is probably the first one to gain such popularity. So the Nest, that's a thermostat that's actually on the internet. It knows what the temperature of your house is. It has sensors to determine whether or not you're home or not home and can adjust the heating and cooling accordingly. It can check to see what times during the day you turned up and down the heat, and could sort of do some thinking based on that. It goes back to a centralized server where it gets processed and actually sent back to the thermostat in your home. Likewise, some of the newer objects are the washing machines that can let you know, among other things, whether or not the load is complete, so you know it's time to put it into the dryer, as well as refrigerators that have built-in smart screens that can tell you, for example, whether or not you're out of milk and display your schedule. So what makes a device smart and what makes it an Internet of Things device? Well, one thing that's commonly found in these kinds of devices that makes them different than regular everyday devices are sensors. Sensors are now available very, very inexpensively. If you see this collection that I have here up on the screen, you can actually buy all 40 of these for like $40, or I think there's like 37 sensors here. Things that can sense motion, they can sense proximity, they can sense distance, they could smell smoke, they can tell air quality if there's just too much CO2 in the air or too much benzene or something else. Heat monitors, temperature monitors, airspeed monitors, tactile monitors, weight monitors, pretty much anything you can imagine can be measured and can be measured fairly inexpensively with one of these sensors. So that's one component that goes into a smart object. Another component that often goes into smart objects are actuators and indicators. These are things that work out in the real world. This example over here is called an electric strike plate. If you've ever been buzzed into like an apartment building, you've used one of these. This device basically, when signal is sent through, when power is sent through it, unlocks a door. This other one is pretty simpler. It's a sort of a siren indicator light. This is a water pump. Here's a fan that you might see on a warehouse, for example. These are all things that do things that could be controlled with electronics and can be part of the Internet of Things universe. Now, it's not really the Internet of Things unless there is some sort of connectivity. And here are 4 popular ways to connect devices to networks where they can interact with other computers. Wi-Fi, very popular. Bluetooth is another one. Some devices are still just plugged into plain old Ethernet connections. And yet another is USB, if you're going to plug a device into another computer. Now, all of these things by themselves don't make a smart device. You need a microcontroller to make it all work, to read the information from the sensors, to act on that information, and to transmit information via the network connections that you just saw. Now up here on the screen I've chosen 4 microcontrollers. This one is an embedded microcontroller chip, and for most mass-produced products this is the sort of thing that you would find on the inside of your smart TV, your cell phone, things like that. But then for things that aren't mass-produced, things that are still in the prototyping stage, or things that are done in smaller volumes, they have other types of microcontroller boards which have been on the market. These 3 are the most popular ones, so they're the ones I'm going to show you right here. The first one is called the Arduino. Second one is Raspberry Pi, and the third one is called a BeagleBone. Now, Raspberry Pi kind of stretches the definition a bit of what a microcontroller is, because it really is a full-fledged computer. It's got an operating system. It actually has output ports here to drive an HDMI monitor. You can plug a keyboard into it, and it runs Linux. But it's often used as a microcontroller. It's about the size of a credit card. It costs about $35. Now, today I'm actually going to be showing you a project that was done here with an Arduino. And an Arduino is probably the first open source sort of microcontroller device to really gain popularity. The Arduino doesn't have an operating system, but it can be programmed in machine code. And I'll show you how that's done in a moment. So let's go and take a look at what our example is going to be today. So what we've done here is we've built a Hello World application, and we actually did this for a real client, and it's something I want to tell you about in the future. I just need to get his permission first. He's signed off and agreed to do this. But basically what this client did was he needed to be able to have an Android tablet with an Alpha Anywhere application running on it. He wanted it to communicate via Bluetooth to one of these Arduino boards. Now, the Arduino board can be hooked up to sensors, and it can be hooked up to alarms, indicators, actuators, all kinds of things that I just showed you earlier in the previous slides. But really for this, he just needed to have a proof of concept. He just wanted to see that we can send information from an Alpha app over to the Arduino board, have the Arduino board send it back to the tablet. So to do that, we used, like I said, in this case, an Acer tablet, used an Arduino board. And because Arduino boards don't actually have the ability to talk by Bluetooth by themselves, we had to choose this little Bluetooth module. Now, the great thing about working with this stuff, if you're new to it, is it's really inexpensive and actually pretty easy to work with. The Arduino board, I think, cost around $14, and this little Bluetooth receiver for the Arduino costs about $6. You can get all this stuff on Amazon, Amazon Prime, have it delivered in 2 days or whatever. It's really pretty amazing for people who've been into this, the revolution that has taken place here. So to make our application work, the first thing we needed to do is we needed to program the Arduino Mega board. And the way we did that is by loading on what's called a sketch. Let me just show you what that looks like. Now this is the Arduino IDE. Here it is running on it's a screenshot of it running on my Mac computer. There's a version for Mac, there's Windows, there's Linux. And all it does is it lets you create software and load it onto the Arduino board. You get this right from the Arduino website. There's no charge for it. Now the programs themselves that you run on the Arduino, you first, if you're using the Arduino IDE, are first written in C. I think it's C#, it may be C. And basically what you do is you create a C program, a small one, and I'll go into a little bit of detail a little later on about how those programs actually work, but I just want to sort of give you the 50,000-foot view on this. And basically you enter in a program and you hit this button over here, which checks the syntax of your script and then uploads it via a USB cable over here to the Arduino. And if you see here on the Arduino, it has a little USB input, so that's how the programs get loaded in. Once they're loaded in, it can be completely disconnected from the power supply. It does not require any batteries or anything to remember the software. And the next time you power it up, the software is run. So once the software was loaded on, the next thing I had to do was I needed to connect up this module here to the board. And for that, I used a breadboard. For any of you who have taken some basic electronics class, this may look familiar to you. Right here, basically, in the background is my Arduino board sitting on my desk. And then in the foreground, you'll see a picture of the HC06, which was the name of that Bluetooth module. And I've got a couple resistors here on board used as part of a voltage divider. Turns out I didn't actually need these. All I really needed to do was just run 4 wires from the Arduino over here to this breadboard with the unit sitting up on there. I'll give you instructions for all this later on if you guys are interested. Anyway, when that's all hooked up and powered on, I was able to find it because, let me just jump back, so I don't want to make you dizzy, but this HC06 module is now a regular sort of Bluetooth device. So I just opened up my handy-dandy Android tablet, and I went into the settings section. And in the settings section, I went and looked for devices, and I found the HC06, which was right there. So once I paired it, so I paired it like you do pair any other Bluetooth device. In this case, it required a password. It was 1234. I think that's the default for all of these units. It was paired to the device, so I could begin using it. So to begin with, I didn't write an Alpha Anywhere application. I just used another piece of software just to make sure everything was working. And the software that I used is called BlueTerm, which you see here on the screen. It's free from the Google Play Store. It's an open source project. Basically, all BlueTerm does is it connects to a Bluetooth device and lets you type in data on the keyboard and get data back. It's basically a Bluetooth terminal, like an old VT100 terminal. So here's a picture of Bluetooth of the thing. I actually took a photo of it. And when I went to connect to the device, it showed me the devices that were available. And it showed me my HC06 device there. And below it, if you take a look, there's a number there, which is the MAC address. There's 2016-04-25-3370. That is a unique identifier to that particular HC06 device. And that's good to know because in the application that we are doing for this client, they're actually going to have a bunch of these things out in the field. So HC06 wasn't enough of an identifier. We really needed to know the MAC address. And Blue Terminal told us what it was. And I'll show you how we use that MAC address a little bit later on. But basically, once it was connected, all I had to do was just start typing letters into the keyboard. Once I clicked on the screen, a keyboard appeared. I could just start typing letters. And I would get, and that would send information out by Bluetooth. It would go into the receiver, it would go into the Arduino. The Arduino would get it, and it would send it back to me. So now is a good time as any to take a look at the script that's behind it. So this script, or what they call in Arduino speak, they call a sketch, is like a little piece of C++. And they're all pretty much the same in terms of their structure. There's always a void portion, and there's always a loop portion. I mean, sorry, there's always, I said that wrong. There's always a setup portion, and there's always a loop portion. The setup portion is for code that you want to run once at the very beginning of the session. And the loop is a loop that the Arduino will keep running over and over and over again. So in this case, I told it in the setup session that I was interested in doing serial communications. So I told it serial.begin, and I told it the baud rate, which is 9600. Down here, I used a couple of other Bluetooth functions that I had in C called serial available, serial write, and serial read. And basically, this loop just keeps looping through an if statement. The if statement reads as follows. If there is serial data available, in other words, if some serial data has been sent by my application, by my Android tablet, to the Arduino, what I want you to do is I want you to read that data, and I want you to write that exact same data back. In other words, I want to echo back anything I send to you, I want to echo back to me. So if I say the letter A, you send back the letter A. If I say hello world, you say back hello world. It's sort of like a very short game of operator. So once that was in place and I saw that everything was working in terminal, I decided then it was time to bring in Alpha Anywhere. So what I did was I created a UX component, which I'll show you here. The top of it has got a couple field labels. There's the to Bluetooth, and here's the to Bluetooth field. I have a connect button. I have a disconnect button. I have a button which says send to Bluetooth. I have another field here called from to Bluetooth and a button received from Bluetooth. Now, probably you guys have already figured out what's going to happen here, but let me just show it to you in working preview so it makes a bit of sense. So here in working preview, basically what you do is you enter in some text into the to Bluetooth box. You click send to Bluetooth, and it appears here in the box when you click the receive from Bluetooth. Send sends it to the Arduino. The Arduino sends it back where it's held in a buffer, and the receive from Bluetooth takes it back from a buffer and puts it into the into that field. So moving down here, oh, Chris, can I do a quick process check to make sure everything is still coming through? It's about 1/4 past at this point.
Yep, everything's going good.
Excellent, thank you.
Sounds
good. All right, it was fabulous. So, meanwhile, I lose my place here in the presentation. Let me just get my place back. So, just placing these objects down into a UX control, of course, doesn't make it work all by itself. I had to write some code behind it, and I needed to write some JavaScript code that knew how to talk to a serial adapter. Now, you're probably wondering, okay, where is that? So, I'll show you. Here in PhoneGap build settings, one of the plugins is called Bluetooth Serial, and that's included with Alpha Anywhere. You don't have to go find this plugin. All you have to do is just check that box. And when you check that box, it includes an open source library, which is documented here on GitHub. And here are all the methods that it can do. So using JavaScript, you can say I'd like to connect to a Bluetooth device. You'll need to know the MAC address, but I'll show you about that in a minute. You can, of course, disconnect. You can write to a Bluetooth device. You could see if there's data that's available to be read from a Bluetooth device, and you could read that data. There's actually quite a few other things you can do with Bluetooth as well. I'm not going to go into this. We're going to keep this really simple for today. So the first thing I did was I worked on the connect button. The connect button, basically, when you press it, here's the event that fires. Bluetooth serial.connect. And remember, I got that from the API documentation I just showed you. And then all you have to do is enter in a MAC address. And I got that from Blue Terminal a little bit earlier on. And then once it connects, like many JavaScript functions, there is a success function and a failure function. So if this works, it fires the success function. And all it does is it displays on the screen, connected. If it fails, it says, did not connect. Pretty straightforward. The next button is the write button. And this is where we'll take whatever information we typed into that box and we'll send it out. And to do that, we just use the Bluetooth serial write function. Again, I got that from the API. And I'm taking the value from the Bluetooth field. And to do that, I did that using dialog object getValue, Bluetooth. Now, to save you a little bit of time, let me just go over into Real Alpha Anywhere. I think I've got this open. I do. Just going to show you a quick thing you can do with this. So here's my send to Bluetooth button. There's my JavaScript. So when it came time to get the value out of the control, I just like to remind people that this is here because it's very useful. There is what looks like a hyperlink, and you'd think that would be for more information, but it's actually a really cool helper. If you say insert UX component method, and you click on that, and you filter down the list to say just get or get value, you can choose one of these, and then when it's inserted, it will actually give you a list, if you right-click here, on your field names. So I'm going to back out of here because I don't want to break my script. But that's probably the easiest way to get that. People often say, how do I read a value out of a control? I just want to make sure that was drop dead simple to show you how to do that. So all this does basically is it takes whatever's in that field and it writes it out to Bluetooth. So it basically transmits it off to the Arduino. Meanwhile, back on the receive side, it's Bluetooth.serial read. And in this case, what it does is it pulls in any data that's sitting in the Bluetooth buffer. And this time we used a set value, and we said set whatever is that data into the from Bluetooth. So let me show you a photograph of how it works. Basically, what you do is you type in, for example, this is a test. Well, first, I'm sorry. To begin, we needed to connect. While it was true that the device was paired, it didn't mean it was connected. Connected means that the app has now opened up a communication with the Arduino on the other side. So we needed to connect. So first we clicked on connect. And when we did that, interestingly enough, it's always cool to see some feedback. And over here on this board, this light was flashing, saying that it's not connected. As soon as I clicked connect, that light stayed solid. So I knew that that portion of it was working. Then I typed in, this is a test, and I clicked send to Bluetooth. This box remained blank. And then the very next thing I did was I clicked receive from Bluetooth. And it took the data that the Arduino had sent back, and it put it back into the box, thus closing the loop and solving the use case that this client actually needed to do. Now, they needed to transmit some more interesting data than this is a test and receive it. And I hope to tell you about it because it's a very, very cool project. And I think we will blog about it in the future. But I just wanted to show you how you can actually get your UX component to talk to an Arduino and how Arduinos can talk to the outside world. So I hope you guys found this presentation to be interesting. And that's about wraps it up. It's a short session today. I don't know if you guys have any questions about the Arduino or something like that, but please type them in now, or you can send them off to guides, G-U-I-D-E-S, at alphasoftware.com. Next week, we'll be back with a regular general session of just general Q&A session and a demonstration at the beginning by DM. But in the meantime, if you have questions or general questions, go ahead and send them to guides, G-U-I-D-E-S, at alphasoftware.com. So I want to thank everyone who attended here today. Before we log out, let's see if it, oh, some other people have written in. Oh, cool. So it looks like there was some interest in this subject, so happy to do a few more of them. Somebody mentioned they have a Strawberry Pi, and which is another similar microcontroller board. There's also the Zigbee, which is another one. There's Edison, which is out there. I see someone's using one of these boards. Cool, great. Well, anyway, just so you know, if you are interested in doing this project, I did make it available for you guys here on GitHub. Let me go ahead and find that for you. github.com/alphaanywhere. So here we are at the Alpha Anywhere site in the repositories section. Just click on repositories. This is github.com/alphaanywhere. And you'll find Bluetooth example. And I put just a couple things here. This is the sketch. That's the portion that you load onto your Arduino. And that's the web component. That's the portion that you use to build the UX that will communicate with your Arduino. So thanks very much for joining. And if you guys have any questions, please go ahead and send an email to guides@alphasoftware.com. Thanks again. Have a great day, and hope to see you next Wednesday. Take care. Goodbye.